Alibaba just launched their most anticipated model ever, Qwen 3.8 27 billion, and it's interesting for a pretty simple reason. It's a 27 billion parameter open-weight model that combines reasoning, vision, video understanding, long context inference, and agentic execution inside one relatively compact model. And it fares even against colossal models like Opus 4.6 pretty well. More on that later. And the word compact is obviously relative here. 27 billion parameters is still a serious model. But compared to the massive frontier systems that usually dominate coding agents and autonomous workflows, this is a size that starts becoming much more realistic for private deployment, workstation class hardware, or your own inference server. It also comes under Apache 2.0, supports vision and video natively, and can stretch its context window all the way to 1 million tokens. At the core, this is a dense 27 billion parameter causal language model combined with a vision encoder. The training pipeline includes pre-training, post-training, and multi-token prediction, or MTP. The native context window is 262,144 tokens, which is already extremely large, and that can later be extended to roughly 1 million tokens. The 27 billion parameter count is also kind of the sweet spot Qwen is targeting here. It's large enough to carry serious reasoning and coding capability, but still small enough that local deployment isn't completely ridiculous. Just for perspective, 27 billion parameters at FP16 would mean roughly 54 gigabytes for the raw weights alone. At 8-bit, you're around 27 gigabytes. At 4-bit, theoretically around 13.5 gigabytes before all the other memory overhead enters the picture. So, no. This isn't something you're casually loading onto an 8GB laptop GPU. But with quantization, multi-GPU systems, high memory max, or proper inference servers, it becomes considerably more accessible than a several hundred billion parameter model. The design is really centered around agentic workloads. That means the model isn't just expected to answer one prompt and stop. It needs to create a plan, use tools, observe what happened, modify the plan, and continue until the task is actually finished. That becomes especially important for things like coding agents, research agents, browser automation, and computer use systems. Vision language capability is integrated into the same model, so it can work with things ranging from stem diagrams to long videos. And reasoning itself is configurable. You can let the model spend more compute thinking through a difficult task, or reduce that reasoning overhead when you just need a fast response. On the serving side, it's also designed to work across platforms like vLLM, SGLang, and TokenSpeed, which matters a lot if you're actually planning to deploy it instead of just testing it in a chat interface. The architecture underneath all of this is probably one of the more interesting parts. Qwen 3.8 27B uses 64 layers, arranged into 16 repeating blocks. Inside each block, you get 3 gated DeltaNet plus feed-forward layers, followed by 1 gated attention plus feed-forward layer. So conventional attention isn't being used identically through every single layer. 3 out of every 4 layers use this DeltaNet-style linear attention mechanism, and then the 4th brings conventional gated attention back into the sequence. For the DeltaNet layers, we're looking at 48 value heads, 16 QK heads, and a head dimension of 128. The gated attention layers use 24 query heads, 4 KV heads, a head dimension of 256, and a ROP dimension of 64. The intermediate feed-forward dimension is 17,408. So the overall strategy here is basically hybridization. You retain attention where it's useful, but you don't necessarily want the full cost profile of conventional attention across every layer when you're trying to process hundreds of thousands of tokens. And that architectural decision becomes much more important once we get into the context window numbers. Out of the box, the model supports 262,144 tokens. To push beyond that, Qwen uses yarn-based rope scaling to reach roughly 1 million tokens. There is an important trade-off here though. You don't necessarily want to turn 1 million token scaling on for every workload. Static yarn scaling can hurt performance on shorter contexts, which is why the configuration is something you modify when ultra-long context is actually necessary. There's even an intermediate configuration where you can use a factor of 2 and target around 524,000 tokens instead. And this distinction matters because supports 1 million tokens sounds much simpler than the engineering reality. Longer context means more memory pressure, more cache usage, and potentially very different inference characteristics. So 1,000,000 tokens is really an upper operating mode, not something you automatically want active for every coding request or chat session. The software engineering results are where this release gets particularly interesting. On SWE-bench Pro, Qwen 3.6 27B was at 53.5. Qwen 3.8 27B reaches 61.7. That's an 8.2 point improvement within the same parameter class. Opus 4.6 Max is listed at 53.4 on the same benchmark. Then you have CoworkBench, which is aimed more toward office and professional agent work. Qwen 3.6 gets 61.0. Qwen 3.8 reaches 70.7. Opus 4.6 Max comes in at 68.2. Terminal Bench gives a slightly different picture. Qwen 3.8 improves substantially again, going from 63.4 to 73.0, but Opus is still ahead there at 78.2. And then on LiveCodeBench v6, Qwen 3.8 hits 90.3, compared with 83.9 for Qwen 3.6 and 88.8 for Opus. So there isn't some clean story where Qwen suddenly wins everything. It doesn't. What's more interesting is that a 27 billion open weight model is sitting in this performance range at all, especially because agentic coding isn't only about generating a clean function from a prompt. The model has to inspect files, understand an existing repository, execute commands, interpret errors, modify code, and ideally avoid destroying something that was already working. That multi-step reliability is where smaller models have traditionally struggled. The same agentic focus carries over into vision. On OSWorld-Verified, Qwen 3.8 reaches 84.3, while Opus 4.6 is listed at 72.7. On AndroidWorld, it's 81.9 versus 62.0. Those are particularly relevant benchmarks because we're no longer talking about ordinary image recognition. We're talking about understanding an interface and then taking actions inside that environment. The visual reasoning results also improve across MathVision, BabyVision, and ChartXiv. MathVision goes from 90.0 to 94.6, with the additional inference configuration being used here. BabyVision goes from 65.7 to 85.6, and ChartXiv moves from 83.7 to 90.2. So multimodality here isn't really being positioned as like, upload an image and ask what's inside it. The more interesting use case is giving an agent visual information that it can reason about while it's doing actual work. Reasoning is also built directly into the model's execution behavior. By default, thinking is enabled. The model can generate an internal reasoning trace before producing the final response. And that internal reasoning can theoretically extend all the way up to the native 262k token context limit. The final answer can then have its own separate output limit. But you don't have to run it this way. If you're doing something straightforward, where extended reasoning doesn't make sense, you can disable thinking entirely and use it more like a conventional instruction model. And I like this approach because different workloads really don't need the same amount of inference compute. If you're asking it to rename 20 files, you probably don't need a huge reasoning trace. If you're asking it to debug a distributed system or independently work through a large repository, that's a very different problem. There's another level of control on top of that called reasoning effort. You get low, medium, and XHigh, with XHigh being the default. Low puts more emphasis on speed and cost. Medium tries to balance accuracy with latency. And XHigh allows the model to spend more effort analysing complicated tasks. But there is an interesting second-order effect here. Reducing reasoning effort doesn't automatically mean your full agent workflow gets cheaper. Imagine an agent is modifying a repository. A high reasoning pass might take longer initially, but if it understands the problem and fixes it in one attempt, that's the end of the task. A lower reasoning run might respond faster, make a mistake, run the tests, fail, inspect the error, try again, fail again, and suddenly you've generated far more tokens overall. So the metric that actually matters for agents is often cost per successful task, not cost per individual model call. And I'm curious what people would actually prioritize here. If you were running this locally, would you rather quantize the model aggressively and leave reasoning at XHigh, or preserve more weight precision and restrict how much reasoning it can do? Because once you're dealing with 27 billion parameters plus a massive KV cache, hardware becomes part of the model selection decision pretty quickly. There's also a feature called preserved thinking, and this is specifically designed for multi-turn agent workflows. Instead of throwing away the previous reasoning state every time the agent takes another action, the earlier thinking blocks can remain in the KV cache. So imagine the model analyzes a bug, forms a hypothesis, edits 3 files, runs a test, and gets another error. On the next turn, it doesn't necessarily need to reconstruct the entire reasoning path from scratch. It can retain continuity between those steps. That's useful for longer autonomous tasks, because repeated reasoning isn't just expensive, it can also create inconsistency. An agent might make one architectural decision in turn 5, and then effectively forget why it made that decision by turn 20. Preserving that state is meant to reduce this kind of drift, while also avoiding unnecessary recomputation. Text, images, and video all go through the same multimodal conversation structure. So a single request could contain written instructions, a screenshot, and a video at the same time. The video side is particularly interesting, because Qwen 3.8 is designed to deal with hour-scale video. But obviously, you aren't feeding every frame of a 60-minute video into the model at native frame rate. For VLLM, the recommended configuration uses frame sampling at around 2 frames per second, along with dedicated video pre-processing. That's an important distinction whenever we hear claims around extremely long video understanding. The engineering challenge isn't only whether the model can understand video, it's how intelligently you represent that video, so you're not wasting the context window processing dozens of nearly identical frames every second. For deployment, there are quite a few options. VLLM is supported for high-throughput serving. SGLang is being targeted particularly toward ultra-long context and autoregressive workloads. Token Speed has dedicated Qwen 3.8 serving recipes. And if you just want to get something running locally without manually building an entire inference stack, Docker Model Runner is another route. There's also the hosted Qwen Cloud API if you don't want to manage the hardware yourself. And this ecosystem support is pretty important. An open-weight model isn't automatically useful just because you can download the checkpoint. You still need efficient batching, memory management, KV cache handling, multimodal pre-processing, quantization support, and ideally an API format that existing applications can actually plug into. The fact that Qwen is targeting several established inference environments makes the model considerably easier to integrate into existing agent infrastructure. There are also separate recommended sampling configurations depending on whether thinking is active. With thinking enabled, the suggested setup uses a temperature of 1.0, top P of 0.95, top K of 20, no presence penalty, and a repetition penalty of 1.0. In non-thinking mode, temperature drops to 0.7, top P goes down to 0.8, and presence penalty moves up to 1.5. Top K and repetition penalty stay the same. And there is one small warning here that's worth remembering. Increasing presence penalty can help reduce repetition, but pushing it too high can cause language mixing. So if you're evaluating the model yourself, it's probably worth starting relatively close to the recommended inference settings before deciding the model is behaving strangely. Sampling configuration can change model behavior more than people sometimes realize. Taken together, I think there are 3 things that actually make Qwen 3.8 27B interesting. The first is portability. It's still a 27 billion model, so hardware isn't trivial, but it's within a class that can realistically be quantized and privately hosted. The second is agentic execution. The coding and computer use results suggest that relatively compact open models are getting much better at actually completing sequences of actions rather than just answering isolated prompts. And the third is multimodality. The same system can reason over text, screenshots, interfaces, diagrams, and video without requiring a completely separate vision pipeline for every workflow. Put those 3 together, and you get something that's potentially much more useful than simply having another strong chat model. You can start thinking about private coding agents, local research systems, internal enterprise agents, computer use automation, and multimodal workflows where sending all of your data to a closed API might not be desirable. And getting started is fairly conventional. The model is available through Hugging Face as Qwen /Qwen 3.8 27B, and the license is Apache 2.0, including commercial use. There's also an OpenAI-compatible hosted API route if you want to test the model without immediately setting up the infrastructure yourself. If you enjoy this kind of deeper technical breakdown, rather than just seeing a benchmark chart and being told one model destroyed another model, you can subscribe. That's basically what I want to do more of here. Reasoning, coding, computer use, visual understanding, video, persistent agent state, and extremely long context are increasingly starting to exist inside a model that you can actually download and operate yourself. And if this trend continues, the distinction between a local model and a serious production model is probably going to become much less obvious than it used to be. That, more than any single benchmark number, is why Qwen 3.8 27B is worth paying attention to.